All right. Hi, everyone. Good morning. Good morning, everyone. Um, Hope you had a good night rest. My name is Irene Cecilia, and with me here is Irene Cecilia, the the pretty damsels. Okay, so today we'll be talking on testing for large data inserts in PostgresQL effectively. And as we all here are developers, it is advisable, it's a good practice to build for the future. Why? This is because we want to mitigate against certain issues that developers face with their products. And it's a good practice as well to build scalable and efficient systems as a developer.
But then again, small projects do not always stay small. With time, you begin to see your application scale. Maybe a big client comes along the way, or your app just goes viral. And then what was once very, very good begins to slow. You now see people complain of slow load times, and you see your customers reach out to you via support with so many bottlenecks. So what do we now do?
I know if I throw out the question now, we'll have different methods of how we resolve such issues. But here we'll be talking about testing, and not just testing, but testing effectively. And for our testing, we are checking for efficiency and correctness to ensure that our data inserts into the DB are correct without errors. And we're checking for resilience. If there's an error, we don't want the data to be corrupted. And we do this by rolling back. We want to roll back to its original state, and if everything works fine, we commit. And then also we want to scale. Scale here, we want to move from, the application should be able to work perfectly from thousands to millions of users, as the case may be. And also check for performance. We want operations to complete in a reasonable amount of time.
We have unit testing, where we actually isolate different individual components to test and to ensure that, what we are working on, the insights, whatever it is working ideally. And then we also have integration testing, where we do an end-to-end interaction and try to ensure that everything works fine between the different components. And then we do performance testing, mostly for speed, where we simulate realistic workloads. You now try to envision what would happen when you go on prod. So that's performance testing.
Okay, here, as you can see on the screen, we want to look at a simple CRUD operation, but then we are looking at the create and the read data handler. So here for the create, we want to insert into the DB or write to the DB. And then here we want to retrieve from it without modifying the data. So here we are reading using the column 2, and then we've logged some errors. Then after that, we have like a simple model, just taking the ID, the fields are the ID, the column 1 and column 2. A simple model for our discussion this morning. So on running the application, so for this application, we are using GOM. So on running it with go run main.go, it migrates the data into the DB. We are using Postgres. It migrates it into the DB, and then we can see that the server is running on port 8080.
So we have actually done a couple of test cases and test scenarios here. We've set up the database. This is the point where we try to connect to the database and try to check out errors, and then we do auto migration, try to migrate the data. And we have a create data test here, where we try to simulate certain scenario in this test suite. We run for valid requests. We also try to check invalid methods and invalid payloads, a couple of other things. And lastly, we'll be trying out a read. Sorry, I forgot to mention. So it's connecting to accessing via a post endpoint. So for the apologies. So for the read, we're trying to read and test for valid requests and data not found via get endpoints. So please continue.
So here we have our main.go file, and as you can see on the screen, our data length is, this is 10,000, and we are inserting into the batches width of length 5,000, and then we insert the transactions. On running this, we can see from the terminal. On running this, we can see the time this finished. It finished as 0.1444 seconds, and this is for. So this is for a typical problem that developers face, and okay.
So she mentioned where we're trying to seed data. So seeding is a situation whereby you try to test with prospective data. So what we did on the first one with little data was to stimulate 100 records rather. And for the second one where we tried to run large data, we increased from 100 to about 10 million. And you saw us use batching. This is actually a very good practice. When you're trying to insert into database, try as much as you can to ensure that you batch your data. And you also see where she talked about resilience. We try to use transaction rollback, transaction commits to ensure that if anything fails, it goes back to the original state. And we prepare the data. Sometimes it's very important, always, not even sometimes, every time it's very important for us to ensure that we have set this up. And for the 100, we had about 0.144 seconds. And then for the large data, where we tried to do 10 million, this is the time it took, 5.7. So you can imagine this when your users are smaller and the time is faster, and then when you begin to scale your application, the load time becomes bigger. So what then do we do? How do we optimize?
Okay, to optimize here, we've introduced, so I know if we ask the question again, we have different ways where we optimize our system. But then for here, we're using the index strategy. And this is just to like increase, this is critical for performance of our system, and especially for large data sets. And yeah, it helps to, instead of scanning the data, instead of like the continuous scan, we want to be able to retrieve data from a particular row or column.
So what indexing does, you can also try to imagine maybe you bought a book, and then the table of contents, you see each topic, it takes you to a particular index in the book. So let's say I want to search for this guy wearing pink. I'm not colorblind, sorry. And in the book, it's telling me that I have to go to seat number 2. So I have to open to search him out. So that is what our indexing strategy would do. It will actually organize our data and enables the DB to always go to the exact place that that record can be found. Is it understood? Okay, thank you. And then we see that when we index for the exact same 100 million record that was running at 5 seconds here. After indexing, we realized that the time it took for the test to run is 0.180 seconds.
Okay, so we just go through all we've talked about. So testing for efficiency, as we said earlier, is we want to insert into our DB without errors. So the things we look out for, we want to benchmark That's we're going to measure the time taken to insert records into the DB under various conditions, as you can find. And then there is query optimization and indexing strategy. We want to be able to retrieve data in a particular row or column without having to like scan through everything. Imagine we want to retrieve from, let's say, column 10, and you want to scan over 10 million data in the DB. So using an indexing strategy, depending on anyone you select or you want to use, depending on your application, it helps to resolve this issue.
So we also tested for resilience to ensure that our data is actually very consistent and very accurate after an insertion, such that even if anything fails, your stuff still stays the same. I know we use it as mostly in my company. I forgot to say. So what we did was to do this test locally just for the course of this presentation. But sometimes it is important to integrate this into your pipeline, your CI pipeline, such that your developers could always know what's exactly or where exactly something went wrong. And also, some teams use chaos engineering and also try to stress test the DB to see what might likely go wrong. And we also did major error handling and also use the transaction atomic, that's the rollback mechanism, to ensure that in case of any failure, in case there is this corruption, our DB doesn't cause any failure, and then again, everything works gracefully.
Okay. And then we're testing for scalability. This is to ensure that high volume data sets, we are able to access database. This is to simulate high volume data inserts to access database capacity. No matter depending on the load your DB can take, or however you want it to, your DB should be able to handle high volume data. Also, for the stress testing, you push the database beyond this limit so as to like identify failure points. And then concurrency testing. Concurrency is something that is very common among Go developers. You want to mitigate against issues like race conditions, deadlock, performance degradation, and all that, to ensure that your system runs simultaneously under different conditions. So verify database behavior under multiple simultaneous insertions.
So we also tried to test for performance. You saw where we did the latency testing, tried to measure the time it took for each insertion. We did the 100, you saw the time it took. We did 1 million, so you could always test for latency in your applications moving forward, because it's actually a very, very good strategy. And then you also can do a throughput testing where you try to determine the number of inserts processed per unit of time. And then you can also try to do your memory usage to monitor it and see the rates your memory consumes during data inserts.
So lastly, so all the talks we've been having is all around effective testing strategies. So these are strategies that are essentials for ensuring scalable, reliable data inserts. And then, by focusing on all these, developers can build robust systems that can handle large data volumes at different stages of their application.
Yeah, so whether you're running a 10 user DB, 100,000, millions of thousands, ensure that you are building scalable and resilient systems such that if your users' volume increase, your application doesn't slow down. And you should also ensure to test at every point so that you can mitigate the issues before it even occurs. So you can connect with us on Twitter, CCG for Cecilia, and Rules Player for me. And here's a link to the repository. That would be all. Thank you.
Thank you very much, everyone.